All right, we are going to repeat the same analysis on our transportation problem, but using QM for Windows instead. We'll have that same given information, but now we need to express it in QM. So here's our information from before. That's our solution. This was the problem. So we are going to make sure we're in module linear programming. Go to File, New, and immediately we're presented with this. So the question is, how many variables do we have and how many constraints do we have? Well, we have, look, we need a variable for everything we get to choose. So here we're making 1, 2, 3, 4, 8, 12 decisions. Okay, those are the 12 things we get to decide. Where to take the output from 3 factories and deliver it to 4 places. So given those 12 things we get to decide, we will pick 12 variables. Now how many constraints do we have? That's, well, Topeka has to be bigger than 9. That's 1. Madison has to be bigger than 7. That's 2. 3, 4. San Diego has to be less than 8 or equal to 8. 5, 6, 7. So we have 7 constraints. And we want to minimize, because our benefit function is travel costs, so we're going to minimize the travel costs. Hit OK. And you're given something that looks like this. So the first thing you're going to want to do is label what each of these different variables mean. So this is New York going to Topeka. And this is New York going to, what is it? Madison, I think. Yeah, Madison, El Paso, and Anchorage. So Madison, New York to El Paso, New York to Anchorage. Right? If I have a 1 here, that means it costs 1 to ship 1 unit from New York to Topeka. So, and we have an actual value here. The actual cost to ship from New York to Topeka is $2,500, right there. So we will put that right there. So let's fill out the rest of these. So next is, so we just finished New York to Anchorage. So now we need, let's see, what is it? Atlanta. So we need Atlanta to Topeka, Madison, El Paso, and Anchorage. Topeka, Madison, El Paso, Anchorage. And next we have San Diego. Oops. So we have San Diego to Topeka, San Diego to Madison, San Diego to El Paso. Oops, did I forget one? Let's see. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Oops, look at that. San Diego to El Paso, and then San Diego to Anchorage. Okay, those are our 12 possible input-output combinations. So now we need all of the costs. So 25, 2015. Oops, that's not right. I need to read it this way. Right, New York to Topeka, then New York to Madison. So that should be 2,000, and then this next one should be New York to El Paso should be 2,500. 2,500, and then New York to Atlanta is, or Anchorage, excuse me, is 8,000. Okay, 20, 30, 15, 85, 20, 30, 15, 85, and then 15, 30, 10, 75. 15, 30, 10, 75. Okay, that is our benefit function. That is the cost that we're going to minimize. So if I ship one good from San Diego to El Paso, you can think about SE taking on the value of 1. So if I ship one good, SE takes on the value of 1. I multiply by 1,000, and that gets me that part of the benefit function. So if I ship 2 from San Diego to Madison and 1 from San Diego to El Paso, I would say 2 times 3,000 plus 1 times 1,000, 7,000. That would be the value of my benefit function if I ship that many goods. Okay, so now my columns are labeled. Let's label the rows. So I have a New York. I have a limit on how many things I can ship out of New York, how many things I can ship out of Atlanta, and how many things I can ship out of San Diego. And then I have a demand. So I have demand for product in Topeka, Madison, El Paso, and Anchorage. Okay, I'm going to save. All right, now I've got my labels for my constraints. So what's the New York constraint? The New York constraint is that I cannot ship more than 10 goods out of New York. So let's look at how you would do that. So let's say, what if I shipped 8 from New York to Topeka and 8 from New York to Madison? Well, that would be too many. So we could so this variable would take on the value of 8, and this variable would take on the value of 8, and that would be 4 too many. So to express that, we say 8 times 1 plus 8 times 1 is too many. So we're just going to count up. This is just 1 times that variable plus 1 times this variable plus 1 times New York, El Paso plus 1 times New York, Atlanta. That expression, those 4 variables added up, needs to be less than 10. Oops. That's interesting. There we go. Huh. I just copied and pasted there. I don't know if that will happen to you. Hopefully not. But that was exciting. So now, let's see. So we need New York to be less than 10. And we need Atlanta to be less than 15 and San Diego to be less than 8. There we go, less than 8. Okay, now Topeka, we need to ship more than 9, more than 7, more than 7, and more than 3. Okay, so more than 9, more than 7, more than 7, and more than 3. Alright, so we've expressed our benefit function. Let's see. So this was these 4 ones, those were the 4 from New York. So New York, Topeka, plus New York Madison, plus New York El Paso, plus New York Anchorage, that needs to be less than 7, or 10, excuse me. So we need to do the same thing for the other cities. So Atlanta, notice now I've labeled this Atlanta, so I'm going to put a 1 in all of the Atlanta cells. And now here I'm going to put a 1 in all the San Diego cells. Now down here, we need to be greater than 9. That's Topeka. So I need to put a 1 in all the Topeka cells. 1, 1, 1, and that's it. So you'll get this pattern. Now we get the Madison cell, here's an El Paso cell, that's an Anchorage cell. Right, Madison cell, El Paso cell, Anchorage cell. If you're systematic about setting up your constraints, this is a very common pattern you'll see. So you'll see a step like, this looks like a step down, and then this is like an alternating diagonals. So those patterns are very, very common when you express constraints in QM. So I've got my constraints, I've got my benefit function, I'm minimizing, so I need to now push the solve button over here and we'll see what we get. Now remember, on our Excel problem, we found that the minimum cost was $62,500, and we figured out a couple different ways to do that. So now we figured out a way to do it by deciding what to ship to everywhere. So I'm going to hit the solve button, and it says we've got an optimal solution. So I'm going to go shoot over here, and lo and behold, the cost to ship the goods through the system, subject to the constraints, is $62,500. But notice now that this time we're shipping 5 from San Diego to Topeka, and over here, San Diego to Topeka, we shipped a little more than 5. We shipped 5.54. So notice QM said multiple optimal solutions exist. So this is a common thing to happen in a linear programming problem. We have many different ways that we can get this maximal solution. So this is one of those ways, but there are others, obviously, since we found 2 already. But in general, that's how you set up a linear programming problem in QM. Notice we didn't put the negativity, non-negativity constraints in. Those are automatically assumed by QM. But we did have to put the other 7 constraints in. And QM is nice in that when you properly label your columns and your rows, it's easier to not make mistakes. But you at a disadvantage of having to write all of these numerals in those cells instead of expressing it more naturally like you did in Excel by just pointing at a cell and saying this needs to be less than some number.